So in this video we're going to talk about symmetry and some different types of symmetry. The first thing we'll talk about is two-dimensional symmetry, and this happens in a couple different ways. The first is line symmetry, and line symmetry is when a figure can be mapped onto itself by a reflection in a line. This is also known as reflectional symmetry. So our faces have line symmetry. If we draw the line right down the middle of the face and fold this in half, then that would be mapped on itself. So almost like cutting it directly in half. If you draw it this way, this would not be line symmetry because the eyes would go to the mouth and the mouth to the eyes, so it's not the same. So we already have a line symmetry. Reflectional symmetry is another word for line symmetry. As we said, in a rectangle we also have reflectional symmetry. I can fold this hot dog style. I can also fold it hamburger style. So I have line symmetry in two different places. The common one that does not exist that people think is the diagonal. So the diagonal is not a line of symmetry, and you can see this if you try to fold a piece of paper on the diagonal. This corner would not map to this corner. That is only the case if it's a special type of parallelogram, such as a square, but it's not true in rectangles or this shape here. And so that is line symmetry. Rotational symmetry is when a figure can be mapped onto itself by a rotation of 180 degrees or less about the center of the figure. So in other words, like if you were to take a kind of put the pin in the center of this and then spin the paper around, when would it look the same? So if it spun around to this corner mapped to here, it would look the same, and then there, and then there. This is kind of tough to see, but this would have rotational symmetry of 120 degrees. And when it goes another 120 degrees at 240 degrees. An extra comma there. And the magnitude of the rotation is the degree of the rotation. So for this one, there's 4 equal parts, and we came up with this because we did 360 divided by 3, because 360 degrees is all the way around. So it goes a third of the way around, which is 120 degrees, and then another third, which is 240 degrees. Here it's split into 4 parts, so I can do 360 divided by 4. So every 90 degrees I'm going to have rotational symmetry. If I move this over here 90 degrees, this point would map to this arrow, and so on and so forth. And so I'd have rotational symmetry of 90 degrees, 180 degrees, and 270 degrees. And 360 degrees will always be true, so we won't say anything about that. This is kind of hard to see with just a picture, so let's look at an animation. So here's an animation. If we push play, it'll count the number of times we have rotational symmetry. So we rotate that around, and there's a total of 3, and I thought the numbers were going to come up, but it maps onto itself 3 times. So let's try the next one here. As this rotates around, you can see that it's not going to map on itself until it gets back to the original, so that does not have rotational symmetry. Oh, there we go, that's what I missed here. Let's move that box. So there it happens once, it happens again, it's the same, and then it happens again, it's the same. So it has rotational symmetry of order 3, and we would say the magnitude is 120 degrees and 240 degrees. So let's look at one more. We'll see as this rotates around that it happens once and then another time. So let's look at the star. You can see as those lines line up, every time those lines line up, that's rotational symmetry. And so it happens 5 times in that star. And the last type of symmetry we'll have is 3-dimensional symmetry. And there's plane symmetry and axis symmetry. Plane symmetry is when you can cut the figure in half with a plane. and then it would map on itself. And so like in this you can't do that, because if we were trying to cut it this way, then I'd have a kind of trapezoidal prism and then a triangular prism, and they wouldn't map in half. And likewise, you also could not cut it this way, as it would not cut the plane in half. So this does not have plane symmetry. Example of something that would be if you had, say, like a rectangular prism, you could cut that in half down here with the plane, or through here with the plane as well. And then axis symmetry is when a three-dimensional figure can be rotated around an axis and be mapped onto itself with the rotation. So a cylinder has axis symmetry because if we drew a line through the cylinder and rotate it around, we would see every time we rotate that around, it would be the same shape. So symmetry is kind of tough to work with, and it really takes just practice, and it's very much a visual thing. So as you work on this, make sure you ask questions, and good luck with symmetry.